Good morning, all of you. I am Dr. B. Satish Kumar from GDC Tech Lab. In this video, I am going to explain very important question is mechanism of ester hydrolysis. This class is most useful to the semester 3 BSc chemistry students. First of all, what is ester? What is ester? Simply, ester is a derivative of carboxylic acid. Derivative of carboxylic acid. What is carboxylic acid? Generally, COOH group containing organic compounds are called as a carboxylic acids. Called carboxylic acids. These carboxylic acids, the OH group is replaced by OR group, or this group is also called as alkoxy group. Those compounds, so it forms RCOR. This is generated from this compound. So this compound is called ester or carboxylic ester. This is called ester. So this ester hydrolysis we are discussing in this video. This ester hydrolysis by using of H2O in presence of two catalysts. First one in presence of acid catalyst. Here acid is concentration H2SO4 we are using for hydrolysis process. In this acid conditions, the bond cleavage between carbonyl group and alkoxy group to form carboxylic acid and alcohol. This is called carboxylic acid. This is called alcohol. The same reaction will takes place when carboxylic acid reacts with alcohol to form ester. So the reversible process is called a Fischer esterification process, reverse reaction. But here hydrolysis reaction now we are discussing. Another condition in presence of concentrated base like NaOH, it forms sodium salt of carboxylic acid and alcohol. This is called sodium salt of carboxylic acid, or simply this is called sodium carboxylate. This sodium carboxylase acid work up, it forms carboxylic acid. So both reaction mechanism discussed in this video. First of all, acid catalyzed mechanism. Here we are using acid is a concentration H2SO4 used as a acid catalyst. So it ionized into proton and HSO4 minus. Here HSO4 minus acts as a conjugated base. So acid is a proton source. It gives H plus ions very easily. So ester, we take ester molecule RCOR. Initially step 1, this is called step 1. Step 1 is a proteination step. This step is a proteination step. Proteination of ester. So the lone pair of electrons of carbonyl oxygen to form proteinated ester. To form proteinated ester. This compound is called proteinated ester. This proteinated ester, this is called step 1. In step 2, proteinated ester attacked by the H2O. So this step is called attacking of H2O or nucleophilication of H2O. So H2O, so lone pair electrons, oxygen containing two lone pair electrons, attacks the carbonyl group of ester molecule to form nucleophilication product OH, OR, OH2 plus. So this is the nucleophilication product in step 3. In step 3, the nucleophilication product, loss of proton, and this proton from changes from this oxygen to this oxygen. This alkoxy group take up this proton to form another oxonium ion. So OH, another oxonium ion, another oxonium ion in step 4. Step 4 is the removal of removal of alcohol. So R COH, OH, OH, R. In fourth step, so the lone pair of electrons, oxygen electrons, come into the carbon and oxygen bond. So the cleavage of carbon oxygen bond. So it forms proteinated acid. Proteinated acid. This form also and alcohol. This is one of the product alcohol. So this is called proteinated acid. Finally, step 5. This proteinated acid RC double bond O plus COH. Finally, HSO4 minus. In final step is called deprotonation step. So removing a proton from proteinated acid. So this HSO4 minus take up this proton. So cleavage of OH bond retain its lone pair of electrons. Carbonyl oxygen again retaining of its lone pair of electrons to form carboxylic acid. Carboxylic acid. This is the simple mechanism of acid catalyzed hydrolysis of ester. The first step is a protonation step. First step is a protonation step. So protonated ester formation takes place. This protonated ester involved in the second step attacking of H2O molecule on the carbonyl carbon to form a nucleophilication product. In third step, the proton exchange from this oxygen to alkoxy oxygen. In fourth step, removal of alcohol to form a proteinated acid. Final step is a deprotonation step. So the HSO4 minus take up this proton to form again H2SO4. So acid catalyzed hydrolysis mechanism is a reversible mechanism. Same way, base catalyzed mechanism. In base catalyzed reaction, so ester RCOOR hydrolysis in presence of a concentrated base NaOH to form sodium salt of carboxylic acid and alcohol. See the mechanism of this reaction. In step 1, is attacking of a OH minus ion or nucleophile. So RCOOR, this is called ester. In first step, OH minus ion attack this carbon carbon. So this double bond is shifted to oxygen. So R, so nucleophilic attack. This is called a nucleophilic attack of OH minus ion. So nucleophilication product we will get in this step. So OH in step 2, removal of alkoxide ion. R, C, ODS, OH. So R, so this bonding electrons comes this side. So alkoxide ion removed. So R, C double bond 1. This OH group right this side. So OR minus. This alkoxide acts as a strong base. So this is called acid, carboxylic acid. So acid base reaction takes place between carboxylic acid and alkoxide ion in step 3. In step 3, acid base reaction. Acid base reaction. This is called acid. This is called base. So it forms carboxylate ion. Already sodium is there in the reaction. In place of NaOH, so sodium is there. So it is a sodium salt of carboxylic acid. So to form alcohol. To form alcohol, this is called sodium salt of carboxylic acid. This sodium salt of carboxylic acid, acid workup, simple H plus ion. So COOH. So carboxylic acid. This mechanism is a irreversible mechanism. This process is also called as saponification. This process is called a saponification reaction. So it is also simple mechanism. Initially attacking of hydroxide ion to form a nucleophilication product. And second step, removal of alkoxide ion. This alkoxide ion acts as a strong base. It is involved in the step 3, acid-base reaction takes place, or exchange of proton from carboxylic acid to alkoxide ion to form sodium salt of carboxylate and alcohol. Finally, this sodium salt of carboxylic acid work up to form carboxylic acid. So this is the base catalytic mechanism. Thank you. Thank you, Manula.